Hey, welcome back to the academic powerhouse with your mathematical meathead himself, the realest guy in the room. Bada bing, bada boom. How you doing? How you doing? Let us continue our discussion on statistics. Let us proceed forth with our journey of understanding, reminding ourselves quickly what we have gone through to arrive where we're at today. We've talked about statistics and defining it as us being able to tell a story of truth through data, through collecting and analyzing and interpreting and presenting data. And like any good story, books, movies, etc., they've got three key elements for them to be good stories: characters, conflict and resolution. And just like a movie, just like a book, statistical stories also have three elements. The ones we have dived into thus far are center, spread, and shape. Now, let's see, what have we done thus far on our broad understanding of statistics? Collecting data, I would say we've done that. We've understand now that in order to collect data, we have to have statistical questions that help us collect data, like a survey or a poll or something where we anticipate answers to be have some sort of variability depending on who you ask and depending on the different context, right? It's not a so there's variability. We've partially analyzed data. I'll say we're kind of on this area in our understanding. We've partially analyzed data. We have partially analyzed data because we have talked about how we can calculate center and spread. We have ways to calculate mean, median, we can determine mode, and when it comes to spread, we've talked about how we can calculate range, inner quartile range, and mean absolute deviation. And when we are able to make these calculations, we can then determine a shape. And we would then therefore have our three elements, right? We have the center, we have the spread, we have the shape. We can then, at that point, tell our statistical story, and then the analysis would be then checked off, which we then can proceed into interpreting and presenting. Let's kind of complete the idea of analyzing data. Now, up to now, our practice problems and my discussions have revolved around giving you numbers, right? And as I just said, we were given numbers. We can then calculate center and spread to get a shape. Well, what if, what if instead of giving you numbers, I gave you the shapes? I gave you the visualizations to start off with. And then I said, hey, let's find out the numbers. Now, one of the many beauties of math is that for everything you can do, so in our case, we can go from a list of numbers to a shape and a visualization. Anything that we can do the reverse. That's part of the beauty of math. So we can start with a shape or a visualization and get numbers, which we then can calculate to get our centers of spread and our centers in our spread. Huh. Interesting, right? For every action, there is a reaction. For every forward movement, there is a reverse. For everything that can be done, it can also be undone. That's the beauty of math. But we're not here to talk about that. We're here to figure out just how, in fact, do we construct these visualizations? How do we, in fact, construct these visualizations so then we can go back and forth? Let's talk about how we construct these. Well, let's first, in case we haven't really said it at this point, let's talk about what these visualizations are. These are the ones that we're going to use for us. Now, in higher levels of math, you may use others, right? Your toolbox will expand, but for now, this is our toolbox, right? These two up here are what's known as histograms. Histograms, and we'll talk about that here in a second. And then we have dot plots. Dot plots. Here we have what's called stem and leaf plots. We have box and whisker. And then we have frequency. Oops. Tables. And like I said earlier, when we have a shape, we can go back and get these, and then we have our whole story, our whole statistical story laid out in front of us. So, but how do we make these in the first place? Because in order to understand how we can convert, we need to understand how we can make these to begin with. So let's run through very high level what each of these are, right? So as I said, I have been giving you lists of numbers here. And so a dot plot, basically, as you saw above, it is a graph. It is a graph. You have your, I guess I'll call it main data points running horizontally. Horizontally means this way, right? You know, that way. So, and then vertically, right? Vertically, and this is true for all these charts and visualizations, true, by the way. And so vertically, you have the occurrences, or the frequency, if you want to call it that. The frequency and the occurrences of the data points that we have given to us. So I'll say frequency, I'll label it so that it's very clear. And the values, the data. Or if you were given, so I just gave you numbers, but let's say these numbers relate to height, or no, not height, but ages of kids at a daycare. Then instead of simply values, it would be ages. And then instead of frequency, this would be number of kids at the daycare, right? But without the context, here we go, right? So I'll kind of I'll kind of construct it a little bit here, just the skeleton of it. Let's see, so 1, 2, 3, 4, okay. And now I'm seeing ages that go from, what's my smallest number here? 4 all the way to 7, right? So I can put here little tick marks that say 4, 5, 6, 7. And you want to try and, you don't have to always, but it's good practice to uh, go by ones, at least at this point in our mathematical careers. Go by ones, right? Each tick mark increments by 1 each time so that you don't get confused. I mean, you could later on, go in increments of 2, 4, 5, 10, whatever, but for us, so it's easy and we don't get confused, let's just go by ones, right? So you see here, I've got ages that potentially go from 4 to 7, and the number of kids that potentially go from 0, this is actually 0, to 4. Now let's see here. Let's see, when I look at these numbers, I'm seeing a single number 4. Just one of them. Just one of them. So, now that we're talking about dot plots, as I said. So, dot plot is basically when you see dots, and you'll see them and they're stacked on top of each other, it just means that the number of occurrences. So let's say this is apple. Well, the way you interpret this is apple, there's 1, 2, 3, 4, 5 apples. So 5 apples, right? So I say that to say, now that we understand that, let's see. I see a single 4, which means 1, 4, a single 4. And that's that. That's that. Let's see, how many 5s do I have? I have 1, 2, 3 5s. 3 5s. So 1, 2, 3 5s. There I go, right there. Let's talk about 6s. I got 1, 2, 3, 4 6s that I've counted. 3 and 4. And then let's see, all I have left are 7s, and I see 2 of them. So I got 1 and 2. That's it, guys. That is how you construct a dot plot. Now, it may get more complicated with more numbers, but this is the basics right here, guys. This is the basics. And look, you can see once you are able to plot these on the dot plot, once you are able to construct this visualization, you can see, you can visualize the shape of our data. Once you have the shape, well, you have the numbers already. From these numbers, you can do, mean, median, mode, range, as we've done before. But what this allows now is you have the shape. So when you have these numbers and you have the shape, boom, you're able to tell the full story of the average age of kids at a daycare, and whatever, however you want to frame that story. So not too bad, right? Not too bad, dot plots. Let's try the next one. We've got a few visualizations, not too much to them, but stem and leaf plots. Stem and leaf plots. As I showed you earlier, it kind of looks like a table. Oops. It sort of looks like a table. Sort of looks like a table like this. The stem, and then you have your leaf. And the way it works is that you basically are saying you're breaking it up by. So remember when you were learning your numbers, you learned what are called the like your tens, right? And your 20s and your 30s. Right? You have tens. You have 10, 11, 12, 13, and so on, all the way to 19. Same thing with 20s. You have 20, 21, etc., all the way to 29, and so forth for the 30s and 40s and such. So the way a stem and leaf plot works is that you're recognizing in all of your data set that you're taking basically all of your 30s, all of your 10s, all of your 20s, and so forth, and listing them out. So for example, let's see, I'm looking here, I see something in my 10s, something in my 20s, and my 30s, and I even see 40s in there. So what I'm saying is, like, on the STEM side of things, what I'm saying is, hey, I recognize that there are values in my data set that fall within the 10s range and the 20s and the 30s and 40s. Now, it doesn't always have to be 10s, 20s, 30s, 40s. It could be hundreds and 200s and 300s and 1 millions and 2 millions and 3 millions and so forth. But here we're just working with small numbers to get the point across. So with that in mind, let's see, let me look at my numbers. Let me scan through my numbers here, and I see one number that falls in this tens category, which happens to be 16. And so the way you state this is simply to say 6. Simply to say 6, right? Because that means when you're interpreting that, you are to interpret that you have one value of 16. So let's hypothetically say here, or for all the tens values, right? For all the tens, right? you would do it like this, right? For 10, 11, 12, 13, you would do 10, 11, 12, 13, 14, 15. And when you do all that, all the way up to 9, when you do all that, you're saying that your data is a 10, and an 11, and a 12, and a 13, and a 14, and a 15, all the way up to and a 19. Does that make sense? Does that make sense? You're just basically kind of splitting it kind of down the center like that. Kind of, you can think of it like that for each one. Let's look at our 20s real quick. I see a couple here. I see, I'm scanning through, I see a 24, I see a 25. So I'm seeing two numbers in our 20s. So as I did, I listed out a 2 to indicate the 20s. I see 24 and I see 25. That's how you would construct it. And when you look at this, you are to interpret then that you have data values of 24 and 25. You have one 24 and one 25. That's how you interpret that when you see it. And this is how you construct it. Let's look at our 30s. 1, 2, 3, 4, 5. Okay, I see 5 of them. So, let's see. Usually you want to put them in order too, right? Smallest to largest. You don't have to, but it's much better to do so. So I'm seeing 34 is my smallest. And in fact, I have, I'll go back to black here. And in fact, I have two 34s. So that's one of them. That's the second. Okay. I also have two 35s. And then I have a 36. So this one is nice because you can see how do you handle when you have multiple 34s, 35s, or multiple of a number that goes in this, the 30s column or the 20s or whatever. There you go. Again, when you see this, you are to interpret, right, 34, 35, 35, right, and then and so forth, right? Just so you see how you can construct it, right? Just splitting it, splitting it. And then you can see if you were just given this just on its own, that's how you interpret it. And that makes sense because up here, those numbers were given. So everything is kind of making sense. And then we have one more to complete this stem and leaf here. One more number, 47. 47. Just like that, guys. Not too bad. Stem and leaf. Now from this, the reason why it's a visualization is because you can visualize that there are a lot of numbers in the 30s. You can kind of think of it as, in a way, a dot plot maybe, or, but like, well, yeah, kind of like a dot plot just flipped on its side in a way, right? You can, if you were to draw your shape as we did on that one, you can see, right? That's kind of the shape that it forms. Now this is a fairly simple example, but when the numbers get fairly large, you could have multiple little hills and valleys and so forth here. That's not the case with our data. Anyways, intuitive, right, guys? Constructing a box and whisker now. This one, I think this is my favorite actually, just because it's such a simple uh, visualization, but you get so much information out of it. So much information out of it. So let's look at our data real quick. Well, again, remember, well, actually, so let me do kind of, whoops. Let me do sort of what we did before. We have our horizontal, and what you are to interpret from that is the tick marks here indicates the data values. So let's see. So as I said, it's best to go in increments of 1. In this particular case, I'm going to you know, to condense it all, I'm going to go by twos. Actually, no, sorry, I won't do that. Nah, I won't throw curveballs at you guys. Come on, I wouldn't do that to you. Let's see here. So, all right, here we go. Let's see. How many do I have so far? Let's see. So three. So I'll do 3, 4, 5, 6, 7, 8, 9. And I'm coming up with these numbers because I'm seeing that my lowest number is 3, my highest number is 18. So 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. There we go, guys. Okay, so with a box and whisker, right? It is going back to the idea that we're splitting our data set into four parts. Four parts. So again, it's the idea of, like I said, four equal parts. Well, if you remember back to when we were doing our calculations of variability, the interquartile range. Well, the reason we do that is so that we know how to or where to put or box off our data sets. In an interquartile range problem, if you remember, we had a Q1 for quartile 1, Q2, and a Q3, and we first went about calculating Q2, which we said was our median, and we said our Q1 was our median of our lower half, and this Q3 was the median of our upper half. Well, it's kind of the same idea. Well, actually, let's find out what those are, because doing that is what's going to allow us to then construct this visualization. So let's erase this real quick. Let's find out what those are so that we can complete the construction. All right, so let me put these in order first. I see a 3, I see 2 4s, I see a 5, I see a 6 and an 8. I'll actually 2 8s, 2 8s, 2 8s, okay, and then a 16 and an 18. And the reason I'm rewriting these and putting them in order is so that I can find out the median. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. If you remember from our median calculation, 2 divided by 9, again 2 because we're splitting it in half, it is 4.5, which means that you count 4 over, 1, 2, 3, 4, and then that very next one is your median. Right, you can do it. So when you do that, the same is true of the reverse, 1, 2, 3, 4, and then the next one. So this is directly, exactly in the middle. So we found out our Q2. Now, as far as constructing things, let's see, we were saying it's 6, right? So I'm going to put a line, just a straight vertical line right here for the time being. I'll even label it as Q2. So there's that piece. Now, let's see. Now we have to, get our median of our lower half. Well, let's see, there's 4, right? So we know that our median is whatever's going to be in the middle of this. Now, we don't have an exact number, but we calculate. We average these two. So 8 plus 16 by 2 equals, let's see, it's 12. There we go. Same thing over here. split it down the middle. There's no exact number, so we average these two. 4 plus 4 divided by 2. In this case, it actually happens to be a 4. So we're inserting an imaginary 4 here and an imaginary 12 right there. So with that said, as you remember, this is Q1, this is Q3. So Q1, I'm going to put a line at 4. And I'm going to put a line at 12. That's not straight. There we go. That's straight. Okay. Now, once we have our 3 quartiles, 1, 2, and 3, it's just a matter then of connecting these together to form boxes. That's where the name box comes from in box and whisker. So we have one box. Here's 1, and here's 2, right? Really big one, 2. Well, what did I say before? That it's all about putting this into 4 equal parts. 4 parts. Well, that's where the whiskers part comes in. That's the whisker. The whisker are the other 2 parts that give us the 4 total to make a whole. Right? So the whisker is simply the range, just the plain old range of the data set as a whole. So, and you remember, right, 18 the maximum minus the minimum. So it's 15. You didn't really need to know 15, but what you do need to know is what the maximum is. So 18. So I'll put a little dot here. It's kind of in the eyeballing it to be in the middle of this vertical line. And then I have a 3, so I just put it kind of eyeballing it right there. So once you have that, you just draw a line to connect it. These lines are what's known as the whiskers. Whisker. Right, whiskers. These are the whiskers. And so now I have 1 box, 2 box, and I have a whisker and a whisker. Well, hey, that's 4. That's 4 parts. That is 4 parts. So now they don't visually look equal, but understand that 25% of all of our possible data points are going to be in each of these different, you know, I'll call them quartiles, 25%. So even though they don't visually look that way, right, because there's a big spread, right? So for example, there's a big spread of data between 6 and 12, right? They don't look it, but in reality, 25% of the data, as we did mathematically, 25% falls within each of these areas. That's the whole idea. So guys, that's it. That's how you construct a box and whisker. Not too bad, right? It's all about knowing how to do your inner quartile range and even just plain range itself, and you got it. You got it, guys. Nothing too bad here. Let's go to the next one here. Histogram. Histogram is probably the most famous of all the statistical visualizations. You'll use it a lot now and even in your higher level maths. Okay, guys, but again, we start with our horizontal line, just like with dot plots. We have our horizontal, we have our vertical, and we're saying our data points, which happen to go, I'm seeing numbers as low as 13, so I'll put a 13 here. And again, this little corner is 0. So 13, and I'm seeing as high as 20. I'll put 21 though, why not? All right, so let's go by ones here. 14, 15, 16, 17, 18, 19, 20. Okay. And then, so that gives me the entire range of my data sets. So again, you can think of the horizontal as being the range of your data sets. And then the vertical, you can think of it as being the frequency or the count. So let's do 4 of them. I don't see any, just in a quick scan, a quick visual scan, I don't see any that occur more often than 4 times. Okay, so now let's look. Let's see how many do I have? I have a, let's see, I see a 13. I see a single 13. So the way it works is you basically build a bar, like a like a like a mini rectangle or bar, all the way up to, so again, I have a single 13. So when I build a bar or a square or a rectangle, if you want to call it, I'm saying that it starts at 13, it goes to 14, it goes up to 14, right? As you know, right? Right now we're just working with whole numbers, but in reality, it means that any number between 13 and 14, an infinite number of numbers. So 13.00001, 13.2, 13.3, etc., all that stuff up to, but not including 14. So there's that. Let's see, do I have any 14s? No. I have a 15 though. So 15, 15, there we go. And I see just one of them. So I'm starting here and I'm only going up one because there's only one of them. So there you go. There you go there. Let's see, do I have a 16? I do indeed have a 16. So why don't I put that? There I go. So I got a 16. Right, starts here. Only goes up one. So just like that, right? I'm including everything between 16 and 17, but not including 17. Because I do in fact have some 17s on their own. Let's see, I got one of them, two of them, any others? Nope. Okay, it's got two 17s. So I go up one, right? One because the one over here, and then two. So two. There I go, right there. There you go, color it in, make it look nice and pretty. Let's see, do I have any 18s? I do. Got one, two, three, and four of them. Okay, all right, wow. Now we're talking here. See, so 4. So I'll just mark that as being the height of 4. And so just all the way up to 4, and then to 19. Oop. Again, my artistry is not the best here, guys. But hopefully you get the point. So it goes up to a height of 4. Color it in, nice and pretty. Let's see, do I have any 19s? No, but I do have a 20, and that's the last one that I can see. So if there's no 19s, there's nothing to put here, so leave it blank. I do see a single 20 though. And there you go, guys. That is how you build out your histograms. Very kind of similar to dot plots, except instead of putting single dots on top of each other, you're just basically creating a little square or a rectangle instead, and just kind of coloring it in. That's kind of the idea there, but you'll see that a lot. And so when you see this written out like this, you can see the shape of our visualization here. The shape is this. You can see the center. You can see the spread. That's why we visualize things. And I believe we have one more left, guys, and that is simply frequency table. So this is a fun little example here. Wait a minute, letters. Wait a minute, wait a minute, wait a minute. What are you talking about? What are you talking about, mathematical meathead? What I would like to illustrate the grades, class grades. Now, a frequency table is exactly that. It's a table, and, as you saw above, right? And grades. You know the grades that you guys got in class, right? A's. You got some B's, C's, D's, and F's. So, if I give you this data set of just letters, right? You just count them up. Count them up. That's all you do. That's what frequency means. The count of them. How many of them are there? So I've got 8 A's. 8 A's in the class. I've got 6 B's. 6 C's. 8. 8 D's. And then 2 F's. So this is nice because it's nice and compact. You don't have to list all the numbers out. It's nice and compact. It's easy to see which one's the most, where the data seems to be concentrated around. The range, it gives you a sense of things here. Um, it is visual, but it's less visual than all the others, but probably the simplest to construct, right? Very quick, easy. So with that said, we've constructed all the major types of visualizations that you need going forward in this class. And after you're able to construct these, guess what? Then you can go in reverse. You can then be given images and then go back. How do I get the numbers from it? Which I'll run through that in a future video, right? But this one was all about constructing it. So now, guys, we have, with this topic out of the way, we are now at a point where we can cross off that we have analyzed the data. So we've done our statistical questions. We've done our analysis of the data. Now we can then interpret data, which we'll do again, like I said, in a future video. But let's get some practice in on converting, or not converting, but constructing the visualizations. Then we'll get some practice in on converting it from visualization back to numbers. Then we'll interpret what some of these, what these mean, right? What do these mean? What does this all mean? Guys, this is exciting stuff. I know, I know, trust me, statistics is very exciting. So, pretty long video, but understand that it's all in the name of getting a pump on, a good mental muscle building exercise today, guys. Feel that burn and go forth. Journey forth in your statistical understanding, journey forth in your mathematical careers, because I promise you, you will not be regretful that you have learned this stuff. You will find much success in your ability to tell statistical stories. Anyways, catch you next time, guys. Thanks so much.